This is section 11.2, arithmetic sequences. And our objective of this section is to find a formula for any term of an arithmetic sequence. Remember, nth just stands for where you are in the sequence. And then to find specified terms of an arithmetic sequence using that formula. So we want to start by considering the arithmetic sequence 2, 5, 8, 11, and 14. First of all, we'll show that it's arithmetic because the common difference between those first two terms is 3. And that common difference holds up no matter which two terms you're talking about. So to get from 5 to 8, you'd add 3. From 8 to 11, you'd add 3. And then from 11 to 14, you'd add 3. To help us determine how to find any term of a sequence, we're going to first determine how to find the fifth term of this sequence. 14 is the fifth term. And you'll notice that in order to find the fifth term, we started at the first term, and we added the common difference 4 times. This pattern follows directly from what we did on the worksheet in class today. Hopefully you noticed that anytime you were looking for the fifth term, you would add a common difference 4 times. If you were looking for the seventh term, you added a common difference 6 times. And we can use that to find terms that you wouldn't want to find by writing out all of the possibilities. So we can continue this pattern for the 100th term. If you wanted to find the 100th term, you would simply add the common difference 99 times. It's 99 because you don't need to add anything to get to the first term. You already start there. So everything after the first term you have to add to get to it. And of course, this isn't just true for the 5th term or the 100th term, but it's true for any term. If you want to find the nth term, you add dn minus 1 times. So here's the formula that we've come up with. In order to find the nth term, that's t sub n, you start with the first term, and you add d n minus 1 times. So here's an example. We want to find the formula for the nth term of the arithmetic sequence, 13, 4, negative 5, negative 14. First, we need the common difference, and I notice that to get from any term to the next, you're going to subtract 9. Which makes the common difference negative 9. So that's one of the pieces of information we need. The other is the first term. And it's clear that the first term of our sequence is 13. Remember, that's t sub 1. So to find any term of this sequence, t sub n stands for the nth term. You're going to take the first term and add the common difference times n minus 1. Notice that in my formula that I just wrote, d and n minus 1 are in opposite positions from the slide you just saw. That's okay because the order of the multiplication shouldn't change your final answer. And now our only job is to put appropriate numbers in the appropriate places. So again, the nth term, the term we're looking for, is equal to the first term plus the common difference times n minus 1. Instead of plus negative 9, you're always, of course, welcome to just write minus 9. And then we want to simplify. So our final answer is that to find the nth term, you take negative 9 times n and add 22. That's a formula to find any term of this sequence. Here's another example, but I'm not going to talk through this one because it's very similar to the last one. Here's the formula, and now we're going to use that formula to answer the rest of the question. Find the 31st term. So to find that, we're going to plug in 31 for n. The 31st term is 8 times 31 minus 5. That simplifies as 248 minus 5, which is equal to 243. Now, it may be tempting to pull out your calculator, start at 3, and just say, well, I'm going to add 8 until I get to the 31st thing in this list. That works okay for smaller things, but we'll use the next example to show why that's impractical, and the formula is actually a better idea. So here we're looking for the 1000th term. Clearly, you're not going to want to add a common difference in your calculator 1,000 times. That's definitely much longer than finding a formula. Now that you've seen one example, pause the video, try this one on your own, And then if you're having a hard time, you can play the video and I'll show you how it goes. Here we go. So the common difference is 10. And it's easy to tell from this sequence also that the first term is 17. We can use those to write a formula for the nth term, which is the first term plus the common difference times n minus 1. And simplifying, we get 17 minus 10n plus 1. Remember, you're distributing that negative, which is negative 10n plus 27. So our formula for the nth term is t sub n equals negative 10n plus. Now that we have a formula, we can use that to find the thousandth term. So we'll use n equals 1,000, which gives us negative 10 times 1,000 plus 27. This is an appropriate time to pull out a calculator. So we can do negative 10 times 1,000 plus 27. And the thousandth term then is negative 9,973. If you need to find many of the different terms of a sequence, the table function in your calculator is really helpful. We use that a little bit in Chapter 10, and we'll review how to use that right now. To use this formula with your calculator, you're going to enter the y equals menu, which that arrow is pointing to. If you already have an equation there, clear it out, and then enter our equation using x instead of n. To get from your equation to the table, you'll choose second and then table. And as you scroll down, you can see that these are the terms of your sequence. Now, you don't want to scroll all the way down to 1,000, so let's talk about how to do that in your calculator. Choose second, then table settings. Then use the arrow keys to go down and change the independent variable from auto to ask. Now, if you go back to your table, you can input any value you want for n and get the nth term of that sequence. The next level of problem is a little more challenging because instead of giving us the entire sequence, they give us just the 8th term and the 12th term, ask us to write a formula for the sequence, and then find the 40th term. So first we need to ask ourselves, what are we missing to write a formula for this sequence? Well, our formula depends on the common difference and the first term. So those are the things we're missing, and there are two ways to find those. The first is to start by finding the common difference using the two terms that they gave us, and then we can work backward if we know the common difference to get back to the first term. It involves a few more steps, but it's a little more intuitive. The second way is to find both the common difference and the first term at the same time by writing a system of equations. Fewer steps, but maybe not as natural to you. We'll start with the first method. So if this is my 8th term, then there's the 9th, 10th, 11th, and here's where my 12th term goes. The 8th term is 60, the 12th term is 48. And of course, I know that to get from one term to the next, you add a common difference. So if I add enough common differences to get to the 12th term, it looks like from the 8th to the 12th, I add 4 common differences. So it must be that the 8th term plus 4 times the common difference is the 12th term. So this is a pretty simple equation. We can solve it for d, subtract 60 from both sides. I get that 4d is equal to negative 12, which means d must be negative 3. Now that I have the common difference, I can use the formula that the nth term is equal to the first term plus the common difference times n minus 1 to solve for the first term. And I have some terms that I can use to plug into this equation. So we're going to use the 8th term because that's one that they gave us. It must be true then that the 8th term is equal to the first term plus the common difference times 8 minus 1. The 8th term of this sequence is 60. So I can substitute 60 into this equation, and now all I have left to solve for is the first term. So 60 is equal to the first term minus 21, which means the first term must be 81. Now that I have the first term and the common difference, I can write a formula. So it must be that the nth term is equal to the first term plus the common difference times n minus 1. And simplifying that, remembering to distribute the negative, we get that the formula is negative 3n plus 84. And now for the second method, we'll find the first term and the common difference both at once by writing and solving a system of equations. We'll use the eighth term to write one equation. It must be true that the eighth term is equal to the first term plus the common difference times 8 minus 1. And so that means 60 equals T1 plus 7 times D. That's also true for the 12th term. We can write a separate equation using that term. The 12th term is equal to the first term plus the common difference times 12 minus 1. So the 12th term of the sequence, which is 48, is the first term plus 11 times the common difference. Now we have two equations with two variables. If we stack those on top of one another, we can actually subtract the red equation from the blue and eliminate that T1. So on the left side we get 12. On the right side, we get 0 minus 4d, and now that's an equation that we can solve for d. We get d equals negative 3. You can take that, put it back into either of your original equations. I picked the first one. And since we know what d is, we can solve for the first term. So since we have the first term and the common difference, we can use those to write an equation. And of course, we're going to simplify this. This is just like we wrote the equation on the previous slide. We just found d and t sub 1 all in one step. But don't forget that our job is to find the 40th term of this sequence. So we have to go back down to that equation we wrote and use it to find the 40th term. So t sub 40 is equal to negative 3 times 40 plus 84. Simplify that, negative 120 plus 84. The 40th term is negative 36. Since this one is so similar to the previous example, I won't talk through it. It actually should be easier because they already gave you the first term. Arithmetic means are just the terms between two given terms of an arithmetic sequence. So if they give you 10 and 22 and there are 3 terms in between it and that sequence is arithmetic, there are 3 arithmetic means there. If there are only 2 terms of the sequence between 10 and 22, we say there are 2 arithmetic means between those numbers. And if there's only 1 term of an arithmetic sequence between there, we say there's 1 arithmetic mean between those numbers. Notice that, though they start and end with the same number, these are 3 different arithmetic sequences because they have different values for d. In the first sequence, d is 3. In the second sequence, d is 4. And in the third sequence, d is 6. We'll use this as an example. Insert 2, 3, and 4 arithmetic means between the pair of numbers. So that means we're going to create 3 different sequences. For part A, we'll start with 15. And there are 2 terms of the sequence between 15 and 45. We need to find what the common difference is to fill in the terms of that sequence. I know that 15 plus a common difference plus a common difference plus a common difference will get me to 45. So it must be that 15 plus 3 common differences is 45. And we can solve this equation for d. 3d is equal to 30, which means d is equal to 10. We can use that value for d then and fill in the missing terms of the sequence. 15 plus 10 is 25, plus 10 is 35, plus 10 is 45. The next 2 examples are very similar, except for instead of putting 2 terms in between 15 and 45, we'll put in 3 and then we'll put in 4. And finally, we'll use everything we've learned about arithmetic sequences to answer an interesting question. How many numbers between 50 and 500 are divisible by 7? We'll begin by writing out a list of numbers that fit our criteria. 56 is the first number bigger than 50 divisible by 7. 63 is the next. 70 is the next. 77 is the next. There are a lot of numbers in this list, so I don't want to write them all out, but I do need to know where this list of numbers ends, so I'm going to pull out my calculator for that to figure out numbers close to 500 that are divisible by 7. 500 itself isn't. 499 is not. 498 is not. 497 is divisible by 7. So since 497 goes in evenly, I know that the last couple terms of this sequence must be 490, then 497. So this sequence, which happens to be arithmetic, it starts with 56 and adds 7 every time, is a sequence that contains every number that answers the question. Here are all of the numbers between 50 and 500 that are divisible by 7. But the question doesn't ask you to list all of them. The question asks how many are there. So you need to know how many terms are in the sequence. If we stopped where my red line was, the answer would be 4. We know that the last term is 497, but we don't know where that is in the list. It could be the 100th thing in the list, but we don't know. We have a variable that we use to stand for where something is in the list, and that variable is n. So we're going to write a formula for this sequence, and we'll use it to solve for n when the term is 497. Let's do that. We know that the nth term is equal to the first term plus the common difference times n minus 1. So there's the n we'll be solving for, because we don't know where 497 is in the list, so n is our unknown. But we do know that 497 is the nth term, whatever n is, so we can replace t sub n with 497. So we'll do that now. And now this is an equation that we can easily solve for n. So we know that when the nth term is 497, n is 64. And since it's the last thing in the list, there must be 64 total things in the list. So therefore, 64 total numbers between 50 and 500 that are divisible by 7.